A single unescaped line of text. That's all it took to expose developers to a serious security risk. CVE-2025-62800 is a reflected cross-site scripting vulnerability in FastMCP, a popular Python framework used for building OAuth-enabled applications. In this video, we'll unpack what went wrong, how attackers could exploit it, and what developers should do right now to stay protected. Let's dive into the details behind FastMCP's reflected. FastMCP is the standard framework for building MCP applications in Python. It's designed to simplify OAuth client handling, that critical step when your app talks to an authorization server and waits for a callback response. It's lightweight, widely adopted, and used in everything from small open-source projects to enterprise integration tools. Because of that reach, a single flaw in FastMCP can impact hundreds or even thousands of downstream applications. Before we get technical, let's break down what reflected XSS means. Cross-site scripting, or XSS, happens when a web application takes user input and includes it in a web page without sanitizing it. A reflected XSS specifically means the malicious input is reflected back immediately, usually through a URL parameter. When a victim clicks a malicious link, the injected JavaScript executes inside their browser in the context of that vulnerable site. That gives attackers potential access to cookies, tokens, or even the ability to manipulate what the user sees and does. In FastMCP, the problem lives inside the OAuth client callback page, a file named OAuth_callback.py. When an OAuth flow completes, that page generates a small HTML response. The function create_callback_HTML takes input parameters like message or error and inserts them directly into the HTML without escaping special characters. That means if an attacker sends a malicious script in one of those parameters, the browser executes it. Essentially, attacker-controlled code runs inside the callback page's origin, the same trusted domain used by the legitimate client. This type of reflected XSS could be triggered in a few different ways. For example, a malicious actor could send a specially crafted link that includes a payload and a query parameter. When a user or automated process visits that link, the unescaped content gets reflected into the page and executes. Even more subtly, a compromised or malicious authorization server could feed a manipulated authorization endpoint back to the client. When the client opens it, the reflected payload executes immediately, right in the victim's browser, under the callback server's trusted origin. If you're finding this breakdown helpful, take a quick moment to hit like and subscribe to Infosec now. It really helps YouTube recommend these cybersecurity deep dives to more developers and defenders. The more people know about these issues, the safer our digital world becomes. Now, let's continue with how this vulnerability impacts real users. The impact depends on how the callback is used, but it can be serious. In many OAuth flows, that callback page runs with privileges tied to sensitive tokens or session data. If attacker-controlled JavaScript executes in that context, it could access tokens, impersonate the user, or alter the callback's displayed message to mislead users. Even if the data itself isn't stolen, XSS in an authentication flow undermines trust. And that's a dangerous place to be. Versions prior to FastMCP 2.13.0 are affected, and everyone should update immediately. The FastMCP maintainers published the vulnerability as GitHub Advisory JVMXX or JV3v6PGC, assigned CVE-2025-62800. A patch was released in version 2.13.0, which escapes user-controlled values properly in the callback HTML. This shows a good example of responsible disclosure. The issue was reported, confirmed, and fixed upstream in a short time. For developers, that means upgrading the library and locking to the secure version in your dependency manager. Here's how to stay safe if you can't upgrade immediately. First, make sure your callback templates escape user input properly. Second, apply a strong content security policy to limit what scripts can run. Third, restrict which authorization endpoints your client trusts. Finally, add web application firewall rules to detect suspicious parameters. These steps can reduce your exposure until you patch. But remember, the best fix is still to upgrade to version 2.13.0 or later. Developers and defenders can watch for unusual patterns in OAuth callback requests. Look for very long or strange parameter values that contain script-like text. Also scan access logs for repeated requests to OAuth_callback.py with odd query strings. Set up automated dependency scanning so you're alerted if FastMCP versions below 2.13.0 are present in your build pipeline. Staying proactive keeps you one step ahead of potential exploitation attempts. Beyond this specific issue, treat every web-facing callback as a security surface. Escape all user-provided content, even if you think it's harmless. Use safe templating libraries and implement automated tests that flag unescaped output. Apply the principle of least privilege wherever possible. Security isn't a one-time patch, it's an ongoing practice of constant improvement. CVE-2025-62800 reminds us that small coding oversights can have big consequences. Reflected XSS is easy to overlook but powerful when abused, especially inside authentication flows. If you use FastMCP, upgrade to version 2.13.0 right now. Review your callback handling, monitor your traffic, and keep your dependencies current. Thanks for watching, and stay tuned to Infosec Now for more breakdowns that keep you safer online.